In today's engineering tips, we're going to cover the two factors that affect the minimum bend radius for your sheet metal or form plate designs. Let's get into it. In today's engineering tips, we're going to discuss the two factors that affect the minimum bend radius in your sheet metal or your form plate designs. We're going to cover some basic terminology, what can happen if the bend radius is too small, and what the inside bend radius should be. First, let's cover some basic terminology. We hear the word sheet metal used often, even for thick plate. However, there is a technical difference. Sheet metal typically refers to material that is less than 3/16 of an inch thick, while plate refers to material that has a thickness of 3/16 of an inch or larger. The concepts that we are going to talk about today are more applicable to plate given the increased thickness as compared to sheet metal. The two main factors that affect the minimum bend radius in sheet metal or plate form parts are its thickness and its material of construction. The purpose of a minimum bend radius is to protect the material during the forming process. Let's have a look to see what happens if our bend radius is too small. Here, in this example, we have a plate of approximately 3/8 of an inch thick, constructed from ASTM A572 grade 50 steel. The inside bend radius was too small for this application, resulting in the plate material tearing or cracking during the forming process. So the question becomes, what should be the inside bend radius based upon the thickness and the material of construction? Fortunately, there are several resources available that provide tables showing the relationship between the inside bend radius, the thickness, and the material of construction. Let's have a look at some examples. Here, this table provides the minimum inside bending radius for various thickness and various alloys of steel. The thickness is given along the top of the table, while the various steel alloys are provided in the vertical left column of the table. Within the table are the minimum bend radii in multiples of thickness T. For example, if we have a plate of ASTM A572 grade 50 that is 1.5 inches thick, then the minimum inside bend radius would be 2 times its thickness, or 3 inches in this example. Here is another inside bend radius table example. However, this one is for aluminum. The table provides the inside bend radii for various aluminum alloys as well as different tempers. The structure of the table is the same, where the thickness is provided along the top, the material construction in the vertical left column, and the inside bend radii within the table displayed in multiples of thickness T. When you search the internet for these bend tables, you'll find a variety of different tables with potentially different values. Most of this variance is due to some tables being defined as the minimum inside bend radius, while others are defined as the recommended inside bend radius. Furthermore, there can be additional variance when factoring in the grain direction of the plate material, as the minimum inside bend radius is larger when bending with the grain versus perpendicular to it. The best approach? Reach out to your internal manufacturing team on the production floor or give your external fabricator a call to find out the recommended inside bend radii they most commonly use. In summary, the two main factors that affect the inside bend radius of your sheet metal or plate form designs are its thickness and the material of construction. Inside bend radii tables can be defined in the form of minimum or recommended for various alloys and heat treatments. If needed, reach out to your internal or external manufacturing partner for inside bend radii that they most commonly use. Let's hear it from you. What are some of your do's and don'ts when it comes to form plate or sheet metal designs? Drop a comment below. Thanks for watching. If there are any questions or anything you would like to see, feel free to contact us or drop a comment below. Don't forget to like, follow, and subscribe to get more engineering tips.